Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a negative 2 millicoulomb charge starts at 0.012 with a velocity of 5 ax meter per second in a magnetic field B is equal to 63 ay webers per meter square. Determine the position and velocity of the particle after 10 seconds. Assuming that the mass of the charge is 1 gram, describe the motion of the charge. Okay, here the question is asking us to find out the position after 10 seconds. Now first we have to know the acceleration in order to find the position, because we have a speed and we need to find out the acceleration so we can find out the position. Now first in order to find the acceleration, we have to find the force. Force is equal to Q V cross B. Okay, Q is what? Negative 2 millicoulomb. So negative 2 times 10 to the power of minus 3. And then V cross B. V is the velocity, that's 5 ax. So I multiply this one by 5, and then that's in the x direction, and then cross with B, that's 63. So when they cross, we are crossing the direction. So we cross the direction, velocity is in the x direction. So ax cross B is ay, and if we cross this one, this is going to give us az. X cross y, that's going to give us z. So this is going to become what? And this one is, okay, this, to make this one simple, let's say 6ay. Okay, 6ay. So 6 times 5, 30. 30 times negative 2, that's negative 60. Negative 60 times 10 to the power of minus 3, that's going to give us negative 0.06. X cross y, that's z. This is our force. Now we have the force, we can calculate the acceleration using this force. Acceleration is what? F is equal to ma, so a is equal to f over m. F over m, and the negative charge remains, and also direction is az. We just have to divide this one by 1 gram. 1 gram is 1 times 10 to the power of minus 3 kilogram. So this is going to be negative 0.06 divided by 10 to the power of minus 3, and that is in the z direction. Okay, if we bring this 10 to the power of minus 3 to the numerator, that's going to become 10 to the power of 3. So if we multiply negative 0.06 by 10 to the power of 3, that's going to give us negative 60 in the z direction, negative z direction. Okay, this is the acceleration. Now we have the acceleration, we can find out the distance. Let's say z is the distance, that's equal to half at square. We know that a is negative 60, and this is meter per second square. This one is Newton. Half at square. A is what? A is negative 60 times t square. We are looking at the position after 10 seconds. So 10 square is 100. So negative 30 times 100. That's going to give us negative 3000. And the direction is z, because this z will be here, right? So the direction is z, and this is meter. So here initially the charge starts at 0.012. Initially it was at 0.12, and we found out this is only traveling in the z direction, right? So this is only traveling in the z direction. So the only position that's going to change is z position. Z initially we had 2. If we add negative 3000 to that, that's going to give us 0, 1, negative 3000 plus 2, that's going to be negative 2998, and this is going to be the position after 10 seconds. And this is the final answer for this question. I hope this helps. Thanks for watching.